Percentages are so helpful. They have so many applications, and I think sometimes that's what makes them a little more difficult to understand. So we can represent parts as a fraction. For instance, on your project where we have to do the population of your city compared to the population of the state, we have that part that goes in the numerator and that whole that goes in the denominator. Your book likes to call this, in the world of percentages, the compared value to the reference value, but you may have heard this before, the statement I said a second ago, the part to the whole. Decimals are nice values because they're standard. They work great in your calculator. This is what we want to type in our calculator. Fractions do have the upside that both parts of the fraction and the actual division of a fraction all have values. So since we have it standardized, we have all those numbers there. But we don't always understand, like if you get 8 out of 14 right on a quiz, people want to know what that quote unquote means. We want to see it standardized into a scale that we're used to. And that's where percentages come in. So percentages mean parts per 100, right? The number cent means 100. So we tend to write it with that percentage sign. Whoops, that's a terrible percentage sign. Sorry. We tend to write it with that percentage sign and a number in front. And what we literally mean is that number is how many out of a standard 100 that is. So this could be converted from a fraction, or it could be found by getting a decimal and then rounding. Let's convert between some of these. So let's say the fraction we have is 1 out of 4 students who are doing some particular something. Because that's 1 student out of 4 students, we don't have the units anymore. We just have the fraction 1/4 here. To make this a decimal, we can divide it. So you can type 1 divided by 4 into your calculator and you will get 0.25. You can also use that F to D button. It's the second of a button on your calculator, and it will convert from fractions to decimals. To get this to a percentage, we need to know how many hundredths this is, and this is 25 hundredths. So this is the percentage 25. Also, some of you may have been taught to get from decimals to percentages, you can multiply by 100. So then how would we get from percentages to the decimals if we needed to put them into our calculator? Then we could divide by 100. So let's try that. If I have the percentage 5%, what is that as a decimal? Well, we know that that's literally 5 parts out of 100 because that's what percent means. So that's the decimal 0.05. Now MyMathLab will not love this fraction. It will want the simplified fraction, which is where both parts are divided by 100. If you're not comfortable simplifying fractions, you can type the 500ths into your calculator as a fraction using that value over a value button and press enter, and it will go ahead and simplify it to the 1/20ths for you. What if we have the decimal? We've done a lot of work to calculate it and we get 0.81. Well, as a percent, we know that that's 81 hundredths, so that's 81%. As a fraction, we know that that's 81 hundredths, and that fraction actually doesn't simplify any. So to get to the fraction, we have to remember it's parts out of 100. To get between percentages and decimals, we have to remember that that's that reflection of in decimal form or in percent form, it's a difference of 100, a multiplicative difference of 100. If you have other values that aren't perfect and they have a few more decimal points in them, we'll see what to do with those in our next example. So this example requires us to do a few different things with percentages. The first is they give us percents. So we've got 40% of female students and they say there's 40 of them. 60% of male students and they say there's 80 of them who are from this college class that are from a major city. And what we want to know is figure out the values. So some of you have heard this is a part percentage problem. I think that tends to overcomplicate it, but we want to know the part given the percentages and the wholes. So let's try to get this in terms of words. What we literally want to know is what is 40% of the female students, and there are 40 female students. That's how many are from a major city. 40% of the 40. So we now know that 40% can be divided by 100 to be written as a decimal, and we like decimals for our calculator. We've learned in the unit section that of means multiply if you've got the value, and then we have 40. So we're going to multiply it by 40, and that'll give us 16. 16 of the female students in that class, 16 of the 40 is 40%, so 16 are from a major city. Similarly with the males, why don't you pause this and try that? You need 60% of how many? 80 male students. Changing this to a decimal so I can type it in my calculator, times the 80 should give us part of that 80, and it does. It gives us 48. So if you've got the percentage and the whole, this is the process that would give us the part. Now on to finding the percentage. So if we want to know the percentage, in this case of total students in the class that are from a major city, we can write the fraction first. That's always nice. And then it'll, by division, be the decimal, and then by multiplication be the percentage. So we want to know the percentage of total students in the class. This is our reference value, our denominator, who are from a major city. This is our compared value. This is our numerator. So how many total students are from a major city? We've got a group of 16 and a group of 48. So we're going to add those two together and get 64. We want to know that 64 as a percentage of the entire class. And we don't have that number, but we do know there seems to be two groups in this class, and one's size 40 and one's size 80. So that's a total of 120. I had to really kind of dissect this question into English or language, or however you want to say that, to understand what the percentage is here. You're going to have to read them very, very carefully. All right, if I divide this, this gives me 0.5. Let's say you accidentally put just 0.53. If you've typed this in your calculator, you notice there's a lot more threes than that. If I went to type this as a percent rounded to a certain number of decimals, then in my calculator I couldn't, or in my MATLAB I couldn't, because I would just have 53%. If my MATLAB or your teacher, which is usually the case, actually wants a decimal point in the percentage to the 10th, we're going to need to make sure that we keep extra values in the decimal percent. So I usually write quite a bit of the decimal percent values and then wait and see how they want me to round my percent before I make any of those values disappear. Does that make sense? So don't shorten your decimal percent too much. You might need those values in the percentage world. Why is this not 50%? Notice we're combining one group, which is 40%, and one group, which is 60%. And we end up with 53%. Because we can't just average percentages. We can't just average percentages is the actual rule that we sometimes say. What we mean, though, is when we're combining these are different size numerators, different size denominators, and we can't just add fractions like that, one. And two, they're actually percentages of different values. So what that means is they're not like terms. Now, if I had like 40% of a group and then 30% of that same group, and those were non-overlapping percentages, those could be combined, but that's a really, really rare case. Traditionally, I'm just referencing very different compared and reference values, and the only way to get the total percent is to go back through and identify all of the weights. That's what we do when we're like calculating your grade for this class, for instance. So let's practice all of those parts. First ones here are going to ask us to do a ratio of our populations. Then we're going to find the percentage ofs, for our populations, and then percentage less or more than for our populations. So first here, we're going to do all the city A's to city B's. So the first question is, what's the ratio or the fraction of city A's population to city B's population? So here's my numerator. Here's my denominator. My numerator will be 1.5 million. My denominator will be 2.9 million. So I actually could just write that 1.5 to 2.9. I don't need all the millions, all the zeros, or the word millions in there because it is a ratio that would simplify to that. Identifying, just for good numerical value, that's about half, right? 1.5 is a half of 3, so it's a little less than 3 in the bottom, but pretty close to half, which is a good thing for us to see as we go on to do the next question. The next question says, instead of a ratio, what is the percent City A's population is of City B's population? And notice that of, if we've got the percentage, we tend to then multiply it by that of because it is the reference value for the bottom. If we're trying to find that percentage, that of is our denominator. So that's that 2.9 with the 1.5 in the top, just like we saw a second ago. I just want you to compare those two wordings so that you can see why we used that same order for this. As a decimal, that's 0.51, let's go with 72. And then as a percentage, we'll multiply that by 100 and we'll get 51.72%. So I divided these in my calculator to get the decimal, multiplied it by 100 to answer the question, what was the percent? And like we said, we expected for that to be around 50, and it was. I'm going to round this just a little further. If we wanted a whole percentage, this would be 52%, so that I can focus in on something going on down here without there being ugly values getting in your way. So this is really the fifth question, but our third question is City A's population is what percentage less than City B's population? Okay. So there's a few ways to calculate this. One is we're actually asked for, we're given the same reference value. We're still comparing this to City B's population. We want to know how much less it is a percentage. Well, how much less is 1.5 million from 2.9 million? If I subtract 2.9 million minus 1.5 million, I get 1.4 million. So what they're saying here is, what percentage less than, how much less in terms of that 2.9 is this 1.4 that we don't have? So 1.4, remember, if we start, once we have the ratio and we know the compared and the full, we can divide it. This is 0.48, it's 27, so I'm going to go ahead and round it to 3 here. It's okay to go ahead and write several of them before we decide how we'll round, which is 48.3%, which would be a great answer, but I want to round it all the way to 48% just to do a comparison here. What do you notice about these two numbers? The percentage of and the percentage less than. If you don't see something right away, I want you to add these two numbers and see what you get. It's 100%, right? Because in both of these cases, we're comparing it to the whole. Here we're comparing what percentage of that whole is City A. Here we're comparing what percentage of that whole is not City A. So there's actually a relationship between all of these percentages here because they're all being compared to the exact same reference value. This is a special type of percentage. It's called the percent change or the percent difference. We'll learn a fancy formula for it, but you'll see you actually won't have to have a formula if memorizing lots of formulas and when to use them is stressful to you. Here, what I had to do is just identify the reference value, which was City B's population, and figure out how much less there was so that I could divide and figure out what percentage less there was. Let's try it the other way. Remember earlier we got like 52%, 48%. What if now, using the same city population, but we want to compare City B's population to City A's population? So here we changed reference values, which is actually a really big deal. 2.9 is now being compared to 1.5 million. Notice it's okay if the top number is larger. That's one reason we've stepped away from the part and whole notation you may have seen before. This is 1.9 with a lot of threes. So this is 193 point, however many threes we want, percent. It's bigger. It's almost twice as big. It's almost 200% of City A's population. Oops, I got a step ahead of myself. I am so sorry. So this is the answer to part B, just the ratio. And this is the answer to part D, the percent. Because we'd already done those several parts on the last slide. I was just kind of flying through. Apologize. Then the question for city B is what percentage more than city A is this? And we are going to calculate it the same way we calculated a second ago. But I do want to write these two things together. City B is 1.93% population of city A. So how much more than city A is? Well, notice in here there's 100%. I want you to type in your calculator what 193.3 minus 100 is. That's 93.3%. Oops, more than. So because it was 193% of, it was 93.3% more than, right? Because it was at 100% and then some extra. So notice that relationship. We can do it just like we did our last one. We're referencing city A's population, so that goes on the bottom. We've already figured out the difference in the two populations is 1.4. And when I divide those and then multiply by 100, I get that 93.3. So notice the last time, because it was less than, they actually combined to 100. Because this is more than, it's actually how much more than 100. But I still want you to start to see how all of these relate together. If you try to work these problems like they're 112 different types of problems, you're going to get stressed. If you try to see how all these problems are related together, you're going to feel lots less worried about it. All right. Let's do some more. Try this one and then come back to the video and check our answers. So a purse is originally $100, but it's 50% off. What's the price now? Some of you will jump straight to, well, it's $50, right? It's 50% off. If it's discounted another 40%, now what is the price? Okay, so this one's a little tricky because it's 40% off of 50. So what this really is 40% less than $50. And so we tend to try to find 40% of $50, which we could. It's $20, but that's not what we're paying. It's $20 off $50. So 40% off of $50 is $20. I'm going to write this two ways. So this is either $20 off of 50 by saying 0.40 times 50. And that's a great way to work this, and I get 30. Or what we could say is if it's 40% less than 50, remember that combining to 100% we said a second ago? What I'm actually paying is 60% of 50, which again would give me that $30. So notice the big difference in off and of. Off of, I had to do some subtraction in there, and once I got the relationship to just of, I could just multiply, because that's what of traditionally means in terms of operations. Isn't this crazy? In both examples, we subtracted. Here we found the 40%, which was 30, or which was 20, and then subtracted it from 50. Here we subtracted the 40% from 100%, and then figured out what part of 50 it was. In either case now, what we have is we're going to pay $30 on a purse that was originally $100. So we're paying 30%. Okay? Because we're paying 60% here of the original 50% that was there. We can't add an average percentages, but we can use the multiplicative property and multiply with them. Why didn't we have to do all that mumbo jumbo on our first problem up here? We did, we just didn't realize it, because 50% off is also 50% of. All right, ready for some more good reading on your homework? We're going to do one more example. Most of you are as good as you're going to get until you've practiced these, but just a reminder, currently the highest tax bracket requires a 37% federal tax rate. If this meant an individual had to pay 37% of their $60,000 income, how much would they pay? That's not actually how taxes work, but if you'll stick around, we will see how taxes actually work and how those income brackets go. But This helps us to see, are we talking about the percentage of, or the percentage less than, more than, or off? It's actually of. So if you can write this statement, some percentage of the total, you can simply work this as the decimal percent times that total. Okay, that's not how we started the last problem, but if that's how you can get it to write it, if you can get there, you can use that. And again, that's going to save you from having to look up a formula for everything. Going to make these a little less painful. All right, let's try our percentage review assignment now. And then if you want to look into those 3A assignments and try to do it from this kind of reasoning standpoint first, you're welcome to. If you get stuck on them, there's several 3A videos that you can go work out as well and check out.